So what is the purpose? Okay, so purpose, as we have clear what the purpose through the definitions. So purpose is to enhance the properties according to our desire. Okay, so if we talk about the increase in the strength and hardness, this is a mechanical properties, right? Because we know the strength and hardness is a mechanical, and we are here to discuss the most of the properties that are related to our mechanical properties, because we are concerned about mechanical properties. Sometimes we are concerned about the physical as well, but and if we talk about the chemical, then it is going to be happen automatically because we are incorporating some other element into the material, right? So increase in the strength and hardness. So alloying elements improve the steel's ability to resist deformation and wears. Okay. So what is the strength? Strength means they will resist the applied load. Okay, before breaking, before failure. So before failure, how much load then a material can sustain is known as strength. Okay. If we talk about the hardness, I have already, taught you what the definition of a hardness. I mean the scratches or the surface of a material that is not going to be respond given you scratch. I mean it's mean there are some kind of resistant property over the surface, so that scratch is identified as not allowed over the material, that is in hardness. Okay, so if you would like to pinch, or if you like to insert some kind of a the very needle type material into the into the harder or hardness material, then it will not allow them to insert in inside the material, that is known as hardness. If they are less hard, then that material will be pinched inside very easily. Or the very simple thing is, if you would like to scratch over the surface of the material, if they will get scratched, it means they are less harder. And if they are not able to scratch anything, it means they are higher hardness. And if they are easily going to scratch, then it means they are very less harder. Okay, so harder and the ductility, they are the just opposite. If they are the hard material, they would be of less ductile. Okay. And if the material is a very high hardness, then it's a low ductility. And if the higher the ductility, the low hardness. Because ductility means you can stretch, you can stretch a material. Okay, very long. If stretch is allowed, it means you can indent, you can scratch the material as well at the same time. And the hardness required the just opposite properties. Okay, so strength, as you can think about, it's a very desirable property, and hardness most of the time is required, right? Because if you are going to uh, make any kind of the component, then they are you basically taking that kind of the material where we are having a need of hardness. Then we can, sometimes we don't need, right? It depends on applications, but strength, most of the time strength is required, because strength is a big and a very major property that is going to be play a very major role in throughout the mechanical engineering, right? So we have, and you can see, I mean, whatever the steel that we see in our home, that as a railing, as a trail of our stairs, that all are of steel, right? And you can see how shining they have, and how strength, I mean strength is also good, and they cannot have other scratches over there, if you will scratch over there, right? So this is a hardness. Okay. And most of the time you have seen this property as well, corrosion resistance. So enhance the corrosion resistance means you would not see any kind of rusting properties or rusting behavior of the steel when they are exposed to the atmosphere, right? Or environmental exposure. So they are not having a corrosion. It means they have a corrosion resistant properties. So they have a capability to resist being corroded. Okay. So corrosion resistance. So element like the chromium and nickel prevents rust and oxidation. So how the rusting is happening? The rusting property is happening due to the oxidation. Oxidation happens through the environment, right? So we know that, I mean, in our environment there are lots of oxygens, and the oxygen present in environment, they get contacted with the material, and they make oxidation, which is a chemical reactions, and they make the material rusted, or you can see as a like a the eroded surface over the material. Okay, so that is known as a rusting. The very common is rusting of iron, which we all see if you have iron rod and you live in an normal environment for a long time, or if you for 1 week or 10 days, then you will see that the surface of that particular material that is going to be eroded, and that would be like a rusting, because the oxidation of the material with oxygen present in the environment, the reaction happens and the oxidation process happen, and due to that the result is of rusting of iron. Okay, so which is not desirable things, right? So most of the time we this is a very negative thing. Corrosion means this is a negative, because in a corrosion your material is going to be eroded and your material is going to be weakened. Okay, so obviously weaken is if the material is going to be weakened, then it means you are basically compromising your safety, right? That is not required. Okay, so mostly we think about, and we try to use the material which have a higher corrosion resistance. Okay, so for that we are having these materials. Okay, and what are the elements that is going to be the responsible for not being corroded in the steel, which is the chromium and nickel. These two elements are very good you know alloying element in the steel, which basically enhance the corrosion resistance. Okay, so improve the toughness. Okay, so alloying makes the steel less brittle and better at the absorbing energy. So what is that mean? If you talk about the brittle and ductility, brittle is just opposite of ductility. Brittle means they are hard. Okay, they can easily, they will not stretch anymore, and they will break suddenly. Okay, but in a ductility material, in a ductile material, that we will see that they are, they're the phenomena which is known as that, it's yielding. It means they are showing you, the material is going to be fail before actual fail. But in a in a brittle material, you will not see, you will not observe any such kind of behavior, but all of a sudden material will get fail, which is not desirable. Okay, but in some applications that we uh, use purposely other brittle material. Okay, not ductile material, so it's depend on application parts. Okay, so alloying metal make still less brittle. It means they are making them a ductile, or you can say that it's a sufficient ductile or less brittle. Okay, so not that much hard, so that we not that much hard means not a hardness. Hard means they are not in a position to be straight. Okay, in that sense hard. If we talk about the hardness, then we will use the word hardness. Otherwise, if hard means they are brittle. Okay, so better absorption energy, it means absorbing energy means what? Whenever you try to deform the body, okay, they will take the energy, okay, before taking. What are the things that is going to be happen through the material? That is the absorbing of energy, because whatever the load, whatever the things that we are applying, they all are the form of energy. Okay, so either they will break, and before breaking, they are basically taking storing the energy inside the itself. Okay, so absorption of energy up to some limit. Otherwise, if suppose you have the capacity to eat something, right? But at some time you can only eat a limited food, right? You cannot go beyond that your saturation limit. It means every material has their saturation limit, how much energy that they can absorb in itself. That is known as the absorption energy. But before after that, the energy will not be stored in the material, and the material will get failed. Okay, that is known as strain energy. So every material has their capacity of storing their strain energy up to some certain limit, and that limit is a limit of failure. If that the energy is exceed, then the material will fail. Okay, so increase the heat resistance. Similar to the corrosion resistance, it is a heat resistance. Means whatever the heat that you are allowing, or that you are, if you are, making your material exposed to the, heat, they will resist. They will not get melted. Okay, up to certain heat. Obviously, every material has their melting point. If you will come close to that melting point, or you can say that, up to that particular temperature, then it will get melted. But up to certain limit, whatever the things, whenever we talk about the heat resistance, it means the normal limit. Suppose aluminum, yeah, right? Aluminum has a limit of 600 something, right? 600 something degree Celsius, having the melting point, right? But could we reach in a real life to that temperature? No. Mostly we are having exposure to our environment, and that have the 50, 60, or sometimes 100 to 150, 200, almost, right? So what I mean, if we talk about our oven that we use to cook our food, right, that all are of around 100, 100, 200, or 150, right? So I mean, up to that limit, which is very common to our society, which are very common to our youth daily life, that is not going to be affected. That is known as heat resistance. It doesn't mean they will not resist, or they will not melt either. That's not right. It means they can resist the normal heat. Suppose if come to come inside the fire, so that can bear, that can resist for some duration. Okay, so that is heat resistant. So normal heat will not basically deform the shape, size of that particular material where it has been used, right? Suppose, I mean, if you can think about a very common example is of IC engine, right? So what happens in IC engine? You can think about in IC engines, lot of heats are being generated through the cycles, right? I hope that you have read in IC engine power thermodynamics, right? So basically, IC engine is a application part of thermodynamics. So if you have read the thermodynamics, then you will move to the IC engine, and you would be observed that lots of heat is being generated when your bike or when your car is being basically run over the road, right? So IC engine is kind of the boxes, or kind of the cylinder where the basically power is being generated. And when the power is being generated, the body parts, or the cylinders that is being used as the IC engines, that are having a lots of heat. So if that material is not sufficient to resist the heat, then they will melt and your IC engine will not work. Okay, so that kind of for the heat resistant is required. Okay, so how much temperature that we are going to reach? Suppose we are in a IC engine. Suppose we are having 2000 centigrade, right? Temperature which we are having in the IC engines. So we must have the material of cylinder of IC engine that can resist almost or around 3000 centigrade, so that we could have in the safe zone. Okay, because all of a sudden your IC engine will burst, and so that is not required. That is very dangerous. So that is against the safety rule, right? So that is why which we concern about the heat resistance. So it also depends on the applications. So it's a very good example of IC engines where lots of heat are being generated, and for that heat, the material which has been used to make a cylinder IC engines, that must be heat resistant up to that limit. Otherwise, it will fail and IC engine will burst. Okay, this is a good example. Okay, so enhance the machinability. Machinability means, I mean, what is the material that as I hope that I have used that word before. Okay, so miscibility means whatever the material that you have, you cannot directly use in your component, in your application part. So you need to make a miscibility, as a very common we have. I hope that you have done in your diploma, that it's a lathe machine. Everybody are aware about that. Okay, so what are the things that we do over the lathe machine that are known as machining? So if machining is easy, it means you can have a low power consumptions. You can make easily that component whatever that you are required in, right? If that machinability is not feasible, or that is not easy, then you would have to come across difficulties. Okay, so that must be of easy. So why? What is machinability? So it's basically enhance the machinability, means they are making easy process to make the machinability over that particular materials. So reduce the wear and tear on cutting tools. What does it mean? The Don't get confused with these the two terms. Wear and tears are not talking about the material. That is talking about the tools, which is basically responsible to make the machining over the material. Okay. So if you have a concern, if you know what is a lathe machine, then the lathe machine has a tool, right? So these two terms, wear and tear, is about the tool. Okay, so tool surface must be very hard material, and that must not be get eroded, or wear tear must not be induced over the material. Otherwise the material, the tool will get failed. And if tool is being failed again and again, it means your material is very not machinable, right? So that you're making it a very it will make you difficulties, right? And that is not required, it's not desirable things, right? So wear and tear on the surface of or on the tool is not required. But if your material is very easy or your material is that much machinable material is there, then your tool will not get failed. Suppose if you talk about the aluminum, right? So aluminum, if you have a experience of machining of aluminum over the to lathe machine, okay, then you must have seen that it's a very easy process. You cannot have a difficulties of reshaping and regrinding of tool again and again, because they are a machinable materials. Aluminums are the machinable material, so they can easily machined over the lathe machine or different. If we talk about the CNC, if we talk about the shaper machine, or even surface grinding, they all are of the machining equipment. Okay, so over all the machining elements, they will have the easiness, and they will not basically provide any kind of the wear and tear over the tool, because it's all about the function of tool. Tool is going to be read, tool is having a uh, build up edge or kind of sharpness has been removed, then you need to regrind your tool, and that is obviously not a desirable thing, because that will make your cost high. That is not desirable, because whatever things that we do, okay, engineering is something kind which is the application of other engineering technology, right, or physical things, or physics, right? But at the same times that we need to concern about the cost, because if some, I mean, you are just making, you have just made some kind of the product which is very good, but they are very costly, so everybody could not afford it. What does it mean? It means your product is not going to be sold in the market, because everybody is not feasible to buy that. It means that is not a desirable things in engineering. Okay, so at the same time you must have to concern about the cost as well.